Hello everybody, welcome back to the next video of electrostatics. So today we are going to discuss a class of numerical based on electrostatic force. Okay, so as given on the numerical, we can see that it said there is a triangle which is equilateral having three equal sides, each of 1 meter, having three charges at the three vertices. Let me name the three vertices as A, B and C. Here is charge QA, here is charge QB, here is charge QC. The magnitudes of QA, QB, QC, which are respectively the charges, are 2 microcoulomb each. Okay, we are asked to find what is the force experienced by the charge that is placed at the vertex C. Now, this is one of the basic level of a numerical that you can get in electrostatic force. Now, there are ways of doing a numerical that would involve vector analysis. So I would give you a particular kind of steps. If we follow those steps, any kind of a vector analytical numerical will become easy to solve. Okay, so now let us see how. So since we are asked to find out the force experienced by the charge C, we need to first understand force being a vector quantity. We need magnitude as well as directions. So what we are going to do is, we are going to find out the magnitude numerically. We are going to assign the directions in the figure, and accordingly along with the directions that we'll be getting, we'll be using vector analysis. Now there are different ways of using vector analysis. We'll be talking as we go through the sum. Now first, let me see what are the force experienced by the charge placed at C. So since there are two other charges apart from this, so this charge is going to encounter two individual forces, one because at A and the other because at B. So let me first write down the force experienced due to the charge at A. So I'll write that force as FCA. Force experienced by charge placed at C due to the charge placed at A. So I'll take it as FCA. Now we will just write down the magnitude. We are not going to do anything, we are not having to do anything with the directions right as of now. So the expression is given by K QA QC by R squared, which should be 1 squared in this case. So we'll substitute the magnitude of the charges here. So if you can also you can also substitute the value of K as well. So that would be 9 into 10 to the power 9 into 2 into 10 to the power minus 6 into 2 into 10 to the power minus 6, which are the same charges, divided by 1. So that would be 1 itself. So your answer would be, this would go as go as 4. So 4 into 9 would mean 36 into 10 to the power minus 3. Okay, so that's the force experienced by charge placed at C due to the charge placed at A. Now we are going to find out the next force experienced by the same charge. So next up, we are going to find out the force experienced by charge C due to the charge B. So again, that would be K QC QB by R square, which is again 1 square here. So since we have the same values for all of the charges as well as for the distance, this would come out as 36 into 10 to the power minus 3 Newton as well. Okay, so now we have found out the individual forces FCA and FCB. We need to find out the total force experienced by the charge placed at C. So in order to find out the total force, which I can write as FC, that will be given by vector addition of both the forces. So the total force FC would be given by FCA plus FCB. Now I cannot add this force directly. I need to go by vector resolution or vector addition. Anyway, I would like to proceed. So our first step is done, finding out the magnitude. That part of the thing is done. Now the next step is to assign the directions. Now as I said, we will be assigning the directions in the figure, and accordingly with the directions we will be solving out the numerical. So since all of the forces are of positive nature, hence the force experienced by charge C due to charge A would be of repulsive nature, because this is positive as well as this. Hence the force experienced by charge C due to A would be repelling in nature. So in which direction will that force be? Now let me show you how to assign the direction. So since this is force experienced by charge C due to A, so we need to know what A is going to do to C. A is going to push away C. So if it's going to push away, so just draw the direction along the line joining the two charges. So this is the direction of force FCA. Again, FCB, force experienced by C due to B. Again, B being a positive charge, he is also going to repel the charge that is at C, right? So B is going to repel the charge along the same line. So repelling along the same line, the direction would be here. Okay, so the directions are to be given at the point of charge who is experiencing the force. We don't need to assign the directions here. Okay, we are not allowed, or we don't need to assign the directions by the charge who is giving the force. Rather, we need to put the direction at the charge who is experiencing the force. That will make it more clear in order to understand the directions, right? So this would be FCB. Now, as I said, there are different ways of doing it. One of the way, since we have two forces, what I can do is, we all know if we are having two vectors, suppose A vector and B vector, and we also know the angle between them, then the resultant vector is given by under root A square plus B square plus 2AB cos of theta, right? This is the formula for resultant between any two vectors. Now force being a vector quantity as well, so we can go by this particular formula to find out the total force. In order to do that, we need to know the angle between them, which is very easy in this case. Since we are given an equilateral triangle, all of the angles in this case would be 60 degree, right? So this being vertically opposite angle, this angle too would be 60 degree. So we know both the forces as well as the angle between them. Hence, for this particular numerical, applying this formula will make it particularly easy for the numerical to be solved in time. So let us apply the formula and get the final answer. So in order to find out the total force experienced by the charge at C, we'll be going by the resultant formula. Now accordingly, if you're going to use the resultant formula, we'll be using A and B as FCA and FCB. So in order to find out the total force FC, it will be given by under root FCA square plus FCB square plus 2 FCA into FCB into cos of theta, theta being 60 degree in this case, right? Now we'll be substituting the magnitudes and we can get the answer. That is one of the ways, right? But since the forces are same, let me take those as x in order to solve the numerical in a pretty simple amount of time. So these are some of the easy and important tricks that you guys need to follow in order to ease up and in order to save time for your endability questions if you're going to appear one. Now let me take this as x. So this equation would look like as x square plus 2 into x, that will again be x square cos of 60 degree. So cos of 60 degree is nothing but half. So this will cancel out. So this will be under root thrice x square. So this will be root 3x. Now you can substitute the value of x again from here. So this would be 36 root 3 into 10 to the power minus 3 Newton. So this is the total force experienced by a charge. Please let's see. So let me first say the steps once again. So in order to solve a numerical that is having vector analysis, the steps are some in this particular order. First of all, we'll be finding out the magnitudes of the forces. That would be done numerically. Then would be assigning the directions. That will be done in the figure. Accordingly with the directions, based on the angles and the separations and everything, we'll be using the vector formula and we'll get the result there. Now, there are some cases where the using of the vector formula might seem a bit difficult. So in that case, we'll be going by the other technique that is known as vector resolution, which we'll be learning in a very short way.